What draws things together? What makes them stick? We're talking about electromagnetic force, right?
Right.
With wise guy Matt Sullen, and we have some really cool contraptions that's going to explain this all. So, Matt.
These are some very interesting contraptions that are kind of dangerous, and you should never try these things at home, especially the one with the shiny red button.
Right. Everything that does something should have a red button like this for effect.
So this is the lunch button that you get to push pretty soon. But anyways, so we talked the last couple of weeks about static electricity and forces between charges that are not really moving. But if you want to have some really big forces, you can also just get charges moving and have an electric current. And when you do that, you create some very interesting effects.
Okay.
One of those is magnets.
Okay.
So maybe everybody in school, and I should have brought this in, but I've done this before, where you take a wire, wrap it around a nail, hook it to a little battery, and you can pick up paper clips and things with that. Because moving electric current creates a magnetic field.
Creates a magnet,
right.
okay.
But the inverse is also true. You can take this meter right here, just measures motion of current, or it measures electrical current.
Okay.
And right now, of course, there's nothing moving because there's no batteries. All there are these coils of wire. These are big coils of wire that are just hooked to that little meter.
They're not doing anything.
They're not doing anything. But if I bring a magnet in and I just wiggle it around near these coils, you'll see that when I wiggle it through the little coil, I get a little deflection of the needle. If I wiggle it through the mid-sized coil, I get a bigger deflection of the needle. And when I wiggle it through the Papa Bear coil down here, right, then I get a big deflection of the needle. So what happens is, basically, when you want to generate electrical current, what you need is a changing magnetic field in a loop of wire. And if you have more loops of wire, you get a bigger electrical current. So if you have a whole lot of loops of wire, which is what we have in the bottom here, the same changing magnetic field, changing just because I'm moving it around, causes this needle to deflect a lot.
What would this be used for in real life? What's the practical purpose of this?
This is how you generate electricity. So over in the Clinton power plant, you have magnets moving through coils, or coils moving around magnets, and that basically produces the electricity that drives the station here and everything else. So all electrical generators work on this very principle.
This is an electric generator.
Right.
Got it. Okay.
Okay. Now, interesting thing is that when you have a moving current, you get a magnetic field. That's the little nail picking up paper clips thing. When you have a moving magnetic field, you create a current, and you can put those two things together to make a very fun electromagnetic cannon, which is what we have right here.
Oh, an electromagnetic cannon.
Right. And so I don't. Do we have a minute left in this? Okay. So
yes,
we'll start to explain this. Okay, good. So we know that if you have a magnet, two north poles of a magnet, like I have right here and right here, when I bring them together, they repel each other.
Okay.
Okay, so North Pole repels North Pole. Same thing here. I have little magnets on this pencil, and if I push them down, because I got the North Pole, they're repelling, and I can get these things actually to go flying off.
Okay.
Okay. So here I have a wire that I'm going to send a current through. It's going to create a magnetic field in this piece of iron in here, and what's going to happen is that magnetic field is going to make a current